Okay, this video is a recap of the class that we had on Thursday and Friday on the 20th and 21st. In class, we used it as a review day to practice least common multiple and solving and adding and subtracting. And in class, we did this notes, a section of the notes followed by an activity to review and practice, and then went back and forth. But I'm just going to do this video of the actual notes that we took in one big clump. So if you missed it, you can just have some extra guidance on these topics. So the first thing we looked at is least common multiple. And our first two examples, there's no pluses and minuses, so we don't need to worry about factoring. We're just going to treat the numbers and the variables as two separate things. So if I'm looking at the least common multiple of 4 and 12, that would be 12. For the variables, this one has 1x and the other has 3x. So you don't combine them into x to the fourth. You just take whoever has the most, which is x cubed. On number 2, same thing. Least common multiple of 8 and 24 would be 24. This one has 4 x's. This has 1. You don't combine them. You just have x to the fourth because that's the most. With the y's, you have 1 and 3. The most is cubed. All right, on the next ones, we do have pluses and minuses. And anytime you see pluses and minuses, you have to think about whether you need to factor first or not. And on this one, on 3 and 4, there's nothing to factor. The least common multiple has got to be a representation of everything that you see. So on this one, the least common multiple is going to be x squared times x minus 3. On this one, it's going to be x plus 8 times x minus 5. Everything is represented. But now if we get to one like 5 and 6, we have factoring in these. And when we have to factor first before we can find the least common multiple. So this one factors to x plus 3, x minus 3. So now when I write my least common multiple, I have an x plus 3 that I need to represent, and I have an x minus 3. Now, both of these do have an x minus 3, but remember, just like we did up here on 1 and 2, we're not combining them, we're just representing them. They each have 1, so the most anyone has is 1, so I have 1 x minus 3 in my answer. On number 6, if I factor this first, I get x times x minus 1, so my least common multiple is going to be x times x minus 1. Everything is represented. On number 7, I have some more factoring. So to factor the first one, this is going to factor to x minus 3, x minus 2. When I write my least common multiple, I have my x minus 2. That part is easy. This one has 1 x minus 3, and this one has 2. 2 is more than 1, so I'm going to take x squared. All right, last but not least, on number 8, factor this, it's going to be x minus 7, x plus 3. And this one is going to be x plus 3, x plus 5. So when I'm writing my least common multiple, I need an x minus 7. Each one of them only has 1 x plus 3. So I'm not going to combine them. I'm going to write x plus 3. Excuse me, to show that we have an x plus 3. And then we have x plus 5. All right. Oh my gosh, I'm so sorry. After we practiced least common multiple, then we did practice more of the rational equations. So in the rational equations, we've got to figure out what the least common multiple is of the denominator. And the first one, the only thing in the denominator is x minus 6. So that has to be the least common multiple. Once you figure that out, we're going to multiply each term times x minus 6. So in the first term, nothing goes away. So I'm just going to have 1 times x plus 6. Well, that's easy. That's just x plus 6. On the second one, the x minus 6 cancels. So I'm just left with 9x. And on the next one, the x minus 6 cancel as well. And I'm just left with 4. This is a linear equation. It's a linear equation because the highest the variable goes is just x. There's no x squared. So I want to solve this just like we did in Algebra 1. Combine like terms. I get 10x. This is not a plus 6. This is a minus 6. I knew there was a mistake because I'm multiplying by x minus 6. I apologize. So we get 10x minus 6 equals 4. and 6 to both sides, so I get 10x equals 10. So x is 1. Now I need to check. If I put a 1 in either one of the denominators, 1 minus 6 is -5. I can divide by -5. That's not an issue. The issue is when the denominator is equal to 0, and then it's extraneous, and we can't do that. All right, let's talk about number 2. Number 2, the least common multiple is x minus 7. So we're going to multiply each term times x minus 7. On the first one, nothing cancels out, so we have to distribute. X times x is x squared, and then we get minus 7x. On this one, I do have a minus, so it's plus a negative, but the x minus 7's cancel, so that just leaves me with -3. Over here, the x minus 7's cancel again, and I'm just left with 5. Now, equation 2 is different than what we had in equation 1. Equation 1 has an x squared. That makes it quadratic. Anytime it's quadratic, you've got to set it equal to 0. So I'm going to subtract 5 from both sides. Now, when you set it equal to 0, you got to make sure it's in the right order. It's got to be x squared, x, and then the number. It's got to be in descending order. So I have x squared minus 7x minus 8 equals 0. So now it's a trinomial with the leading coefficient of 1. So I'm going to go straight to my 2 parentheses. The two numbers that multiply to -8 and add to -7 would be -8 and +1. So when I solve, I get 8 and -1. And now I need to check. If I plug in 8, 8 minus 7 is 1. If I plug in -1, -1 minus 7 is -8. Both things are fine because they're not 0. All right, let's look at number 3. Number 3, my least common multiple is x plus 4. So I'm going to multiply everything times x plus 4. So on this one, I'm going to distribute, and that gives me 2x squared plus 8x. Here they cancel, and I just get plus 3 equals, over here, nothing cancels, so I have to distribute, and I get x squared plus 4x. Okay, again, it's quadratic because it has an x squared. And when it's quadratic, you have to set it equal to 0. And we want our x squared to be positive. So I'm going to move x squared to both sides and subtract 4x. That gives me x squared plus 4x plus 3 equals 0. Okay, it's a trinomial with a leading coefficient of 1. So I'm going to go straight to my 2 parentheses. And the two numbers that multiply to 3 and add to 4 would be 3 and 1. So we solve, x equals -3 and -1. Okay, last one. When we're writing our least common multiple, just like we talked about, the least common multiple has to represent everything. So there has to be an x plus 2 and there has to be an x minus 2. So each term is multiplied by the x plus 2, x minus 2. Let's get this over. Okay, so in the first one, the x plus 2's cancel. So now I'm going to distribute this, and that gives me 3x minus 6 plus. Here, the x minus 2's cancel. And this gives me 2x plus 2 equals the last one, x minus 2 cancels. Distribute the x, so I get x squared plus 2x. It is quadratic because I got an x squared, but no matter what kind of equation you have, before you solve it, you always want to combine like terms. So 3x and 2x is 5x. And this gives me -4 equals x squared plus 2x. All right, now I need to, oh guys, I distributed wrong. Over here, when I distribute the 2, I got 2x, and here I got 4. Oh, wow, I'm struggling today. Okay, so now when I add them together, I get -2. All right, let's see if we can make this work. So it's a quadratic equation, and we need to set it equal to 0. So I'm going to subtract 5x from both sides, and now I need to add 2. Okay, I'm keeping it in descending order, and I am doing it, keeping my x squared term positive. All right, now that we have a trinomial and the leading coefficient is 1, I can go straight to my 2 parentheses and the two numbers that multiply to +2 and add to -3 would be -2 and 1. So when I solve, I get 2 and 1. But now I need to check. If I plug in 1, this gives me 3 and -1. That's not a big deal. But if I plug in 2, this gives me 4. No big deal. But here, 2 minus 2 is 0. And we cannot have 0 in the denominator. So this 2 is extraneous. Now, if you're in an even class, you're going to have a quiz on Tuesday next week. And if you're in an odd class, you're going to have a quiz on Wednesday next week. And on the quiz, there'll be a blank for your answer. And if you were doing number 4 on the quiz, I would expect you to write both 2 and 1 on the answer blank and then mark the 2 as being extraneous. All right, the last thing we did was reviewed adding and subtracting. Adding and subtracting also uses the least common multiple. But notice in all of these problems had an equal sign. When we're adding and subtracting, we don't have any equal sign. When we are solving, our final thing is going to be x equals a number. When we are adding and subtracting, our goal is to take the two fractions that we have, like here's one fraction, here's another, and we're trying to combine it into one fraction. Okay? And to be able to add fractions, we have to have common denominators. So on number 1, the least common multiple of the denominators is just 4x minus 1. And the nice thing about problem 1 is the denominators are already the same. So now we're ready to merge it into one fraction. When we do that, the denominators stay the same, which is our least common multiple, and then we combine like terms in the numerator. So 6x and x is 7x, and -8 and 3 is -5. Only when we get it to one fraction, that's when we can try and simplify. You cannot simplify before then. But 7x minus 5 doesn't factor. We can't simplify it further. We're done. All right, let's look at number 2. On number 2, I do want to acknowledge that because it's a minus, I'm going to make it a plus and negative. But I cannot determine my least common multiple until my denominator is factored. And this is going to factor to x minus 7, x plus 2. So my least common multiple is x minus 7, x plus 2. Okay, so now that I know my least common multiple, now my goal is to write it into two fractions, or the first goal. And when I write it two fractions, I want both fractions to have the same denominator, and that same denominator is going to be my least common multiple. Now this fraction over here on the right, its denominator is already the least common multiple. I don't need to change it, so this is going to remain -2x. But the fraction on the left, it's got the x minus 7, but it's missing this x plus 2. So I need to multiply it times x plus 2. Now I'm multiplying a binomial times a binomial. So you got to FOIL or distribute, whatever you want to say. 3x times x is 3x squared. 3x times 2 is 6x. 2 times x is 2x. And 2 times 2 is 4. Now, at this point, you cannot do any simplifying. You cannot simplify until it becomes one fraction. So now I'm going to write it as one fraction. So I have x minus 7 times x plus 2. The denominator remains the same. Now we're going to combine like terms in our numerator. So I'm going to have 3x squared. 6 and 2 would be 8. Minus 2 is back at 6x. And then I've got plus 4. Now, we could check and see if the top factors, 3 times 4 is 12. But are there any numbers that multiply to 12 and add to 6? No. So we don't need to do anything. So we're done. All right, let's try this again on number 3. Number 3, my least common multiple is going to be x minus 5 times x minus 8. So now the first goal is to write two fractions that have the same denominator. Okay, my first fraction has the x minus 5, but what it's missing from the least common multiple is x minus 8. So now I'm going to multiply that and distribute. So that gives me 5x minus 40. The second fraction has the x minus 8, but it's missing the x minus 5. So now I'm going to multiply and distribute, so I get x minus 5. Now that they both have the same denominator, now I can merge them into one fraction. That is the ultimate goal. In the numerator, I'm going to combine like terms. 5x and 1x gives me 6x. Negative 40 and negative 5 is negative 45. It's only when I have one fraction I can see if it can simplify. Yes, I could take a 3 out of that, but if I take a 3 out, that leaves me with 2x minus 15. That's not going to factor, so I don't need to, it's not going to reduce, excuse me, it's not going to reduce anything. So there's not necessary to do that, but if you wanted to factor the top, you certainly could. Okay, last one, number 4. You cannot find that least common multiple until everything is factored. So this is going to factor to x plus 2, x minus 2. So my least common multiple is x plus 2, x minus 2. So the first goal is to write two fractions that have the same denominator. The second fraction over here on the right, the denominator already is the least common multiple. I don't need to change anything, so I'm just going to leave it as a 3. Notice when I write my least common multiple, it's in factored form. When I write my denominator, it's in factored form. You don't multiply them back out. Okay, back over here on this first fraction, it has the x plus 2, but what it's missing from the least common multiple is the x minus 2. So I'm going to multiply that, and that gives me 7x minus 14. Now that I have two fractions, my next goal is to merge them into one fraction. So the denominator stays the same, x plus 2, x minus 2. And now we're going to combine like terms and get 7x minus 11. It is only at this point that I can see if something reduces, but because 7x minus 11 doesn't factor, that will not reduce. All right, that is what we did in class.